Hi, let's take a look at an example of one of the special cases of projectile motion. So in this problem, we have a plane that's flying horizontally at a speed of 300 meters per second, and it's flying at a level altitude of 1,470 meters. And it's supposed to release a package of supplies just so that the supplies land outside a town that's an unknown distance away. So we need to calculate how far away from the town we'll need to release the supplies so that they end up where they're supposed to be. So this is a case of zero launch angle, because if the plane's flying relative to the ground that at a constant altitude, then that's 0 degrees, zero angle, and any object that is part of that plane that gets let go of and made into a projectile, that's going to have to initially have the exact same velocity as the velocity of our plane. So that object also has zero initial launch angle. So from the facts of zero initial launch angle, if our launch angle is 0 degrees, our velocity in the x direction is our initial velocity. Our initial velocity in the y direction then has to be 0. And our change in y is always going to be minus the height that the object fell from if it has zero launch angle. And we're dealing with flat ground. So, in terms of our equations for zero launch angle, our range, our distance that we travel, is going to be our speed in the x direction times the amount of time that we have. So we know our speed in the x direction is 300 meters per second, and then we need to find the time. Well, for objects with zero launch angle, the time the object falls is going to be the square root of -2 times our change in y, which is always going to be negative, so we'll account for that negative sign in the square root, divided by the strength of gravity, which when we write things as the strength of gravity g, it's always a value of plus whatever the strength of gravity is for our object. So on Earth, 9.8 meters per second squared. And the last equation that we'd make use of with zero launch angle is finding our final velocity in the y direction. Our final velocity in the y direction would have to be the square root of -2 times the strength of gravity times our change in y. And again, that negative change in y is going to get rid of that extra negative sign that we have here. So, to figure out the distance, to find the time of the fall, we'd have -2 times -1,470 meters, the initial height of the plane, divide that by 9.8 meters per second squared, and that would give me, under the square root, 300 seconds squared. I take the square root of that, and the time of the fall is going to be 17.32 seconds. So now, my distance would be 300 meters per second times 17.32 seconds, which to 2 digits is going to round to 5,200 meters. Now, if we want to figure out how fast everything would be going, then we need to take a look at finding our final velocity component in the y direction. So if I take -2 times 9.8 meters per second squared, multiply that by -1,470 meters, and then take the square root, I get a y component to my final velocity of 170 meters per second down. So our final velocity in component form would be 300 meters per second I hat minus 170 meters per second j hat, or in magnitude and direction notation, I square both sides, add them together, take the square root, following the Pythagorean theorem. So that would give me a magnitude of 340 meters per second at an angle of -29.5 degrees. Now, this is incredibly close to the speed of sound. And if these are things that are potentially fragile and we don't want them to break, then we would need to do something in order to lower that speed. So what can we do? Well, In situations where pilots need to deliver emergency supplies, but they don't have the safety of being able to land and unload the plane, and they don't necessarily have the luxury of parachuting things in because the time that the objects take to get to the ground using a parachute is a lot larger, giving other folks time to intercept those supplies. What you can do is try and fly the plane as low and slow as you can. So what they'll often do, most military grade cargo planes have rollers in the back, so they can open the door, unlock the rollers, and then as the plane's just barely flying above the runway, the pilot accelerates. So applying Newton's laws, the force of the engines accelerate the plane forward. Those packages keep moving at the original velocity of the plane, and they basically roll out from off the plane because the plane is accelerating out from under them as the pilot then tries to climb and gain altitude as quickly as possible. Thanks for watching.